Hi, everyone. Good morning, good afternoon, and good evening to everyone joining from all over the world. And thanks for making the time and joining this session. I'm Ashish Mishra, and I work on strategy and business development for cloud at SES Networks, the largest global satellite communication provider. Satellite communication market has been expanding rapidly recently, with new satellite constellations with thousands of satellites each announced in the past couple of years. I'm going to talk about the role that cloud and SDN are playing in making this possible, and perhaps also plant the seeds of where this can help you develop and expand your current connectivity offerings. Now, because of the recent marketing push by some of the major CSPs in the space market, this will reaffirm some of the ideas that you may have read before, and hopefully also add some context behind the drivers. I'm going to start with a statistic that, if anything, you'll find conservative. At least 9 out of every 10 companies with more than 1,000 employees use cloud or cloud native services. But terrestrial networks, and these are both wired and wireless, cover only about 20% of the earth. Now, that 20% houses most of the population, but the resources and industry are dispersed all across the globe. Oil fields, gold mines, maritime operations, planes flying across the sky are not bound by that 20% geography. Now, if a company has all of its branches and assets in urban centers, then the terrestrial connectivity serves them very well. It's cost efficient, and because of diverse providers, the resiliency is typically pretty good. However, if you happen to be in the other 70%, then you have at least one branch or asset that is either in a remote location that is underserved by terrestrial connectivity, or it's a mobile asset, ships, trains, and planes. Now, when I say underserved, I also include the scenarios where an important asset like a factory or a mine or a farm is connected by a single connection, which can sometimes be of questionable reliability. This is quite common on islands where there is a single submarine cable serving the place, but it is also common in rural and landlocked regions. So, as an IT organization that's trying to transform the operation and move the workloads to the cloud, these remote and mobile locations pose a problem. Without a high quality connection, with low latency and high reliability, you're stuck with running your old IT stack in those locations while your urban centers can run the new cloud based applications. Running two IT systems is both expensive and complex, but that's where satellites offer the solution. Until about 5 years ago, the only satellite connectivity option that was available at scale was through what are called satellites. These are satellites in the geostationary or geosynchronous orbit, about 36,000 kilometers from the Earth, which results in just under 600 milliseconds latency. But because of this distance, these satellites can only deliver up to about 100 Mbps at any location. That being said, this connectivity is incredibly robust and cost efficient. More recently, however, O3b Networks, which is now part of SES, launched satellites in the medium Earth orbit, which is about a quarter of the distance compared to geo satellites. And they started offering hundreds of Mbps up to 2 gig to a single site with under 150 millisecond latency. This connection then delivers a fiber-like experience. This has resonated very well with customers that predominantly have remote or mobile assets like mines, cruise ships, island nations, landlocked countries. And the acceleration in cloud transformation that we've been seeing recently has encouraged other entrants in these non-geostationary orbits. So what this is enabling now is that being off the grid no longer means that your branches are offline. They're always connected, wherever they are on the planet, with a fiber-like connection to your workloads in your private or public cloud environments. Being remote or on the move is no longer a barrier to being in real-time contact with all of your other business locations across the globe. And you can now deploy and make the most of your intelligent edge infrastructure with the assurance that it is connected to the associated intelligence in the cloud. Now, while cloud is creating the opportunity and enhancing the role of robust networking in this enterprise value chain, SDN is unlocking the ability of satellite connectivity providers to operate these massive and complex mesh networks in space, um, and offering the ability to seamlessly integrate satellite connected assets and fiber connected branches to each other and to the cloud. Now, given the scale of these new constellations, some of them having 100, 500 to a few thousand satellites each, automation and orchestration of the satellites and the terrestrial network that they create is a fundamental necessity. For the most part, they leverage the work that has been done in the telco world for network and radio resource management. But there is an added complexity of the time dynamic nature of satellites. They are moving at a very high velocity relative to the Earth. They are sometimes not in the equatorial orbit, which means they have relative velocity compared to each other within the same constellation. So it is a very dynamic mesh network that these satellites create. Um, until recently, there wasn't enough computing power on the satellites or on ground, or the right technologies available to be able to manage this efficiently. Um, Now, with more cloud resources being available and progress in temporospatial SDN, there is the necessary systems in place to enable these hyperscale constellations. There's a paper on temporospatial SDN by Brian Barrett from Google on this subject, if anyone's curious. Now, because the technological and operational barriers for these mega constellations have been addressed by the market created by the cloud and techniques based on SDN, there has been an exponential growth in the amount of investment in satellite communications over the past 6 years, and it has been driven predominantly by venture capital. Um, Starting in 2014, where the investment was less than $1 billion, and most of it coming from acquisition of different companies, it has consistently been moving up. And in 2019, it crossed about $5.7 billion. Now, this investment has also not been completely limited to US companies. More than half of the recipients were from outside the US. Um, Starting 2019 and also in 2020, there were more than 70 non-US recipients of grants and funding in the satellite space. Now, another major change that has been seen has been the nature of new entrants with large planned investments in space. Amazon with Project Kuiper and SpaceX with Starlink are planning to launch thousands of satellites over the next 5 years. SpaceX has already launched over 500. Microsoft recently announced Azure Orbital, which is their satellite ground station as a service offering that provides communication and control for satellites. And there has also been news from Apple and Google of their space-related ambitions. This investment is matched by progress from incumbents, with SES launching the next generation of its MEO satellites next year that will deliver up to 10 gig of uncontrolled bandwidth, connecting just about any 2 points on the planet with less than 150 millisecond latency. So the future of the industry is a connected future, and satellite connectivity is going to play a key role in bringing the other 80% of the unconnected Earth closer to centers of cloud and commerce. And the new future of satellite connectivity is ubiquitous, low latency, and high bandwidth. Hopefully, we'll have enough time now for questions, but please reach me over email or LinkedIn if you're curious about the role satellites will play in enhancing the telco and cloud value chains. Thank you. Hi, everyone. Now we have some time available for questions, if there are any. I see a few of you are dialed in. Um, if there are no questions, please feel free to reach me over email or over social, and we can talk more about these subjects. Okay, I think there's a question by John. Where in the satellite value chain do you see the key security of SD-WAN being required? Um, so there are a large number of use cases, and I'd say predominant number of use cases um, where satellite connectivity is not the only connectivity mechanism that is available at a particular location. Um, there is going to be either a fiber, LTE, or some other form of connectivity to a place, but maybe it's not as reliable, or maybe that place is prone to natural disasters. Um, in those scenarios, if there is a combination of multiple media, um, we see SD-WAN being deployed quite frequently. Um, the security aspect itself is very much dependent on the kind of applications that the customer is using. If those applications tend to be very critical for their operations, if they're running um, very strongly encrypted applications themselves, they perhaps won't go with the overhead on SD-WAN. But in general, for corporate applications, it's just better to bundle it inside of the IPsec that's available. Um, so yeah, I hope I got the answer across. The more important piece is the ability to blend the capacity between multiple different WAN connections. Now, keep in mind, there is a particular nuance about using two different types of connectivity mechanism as different as satellite and terrestrial. Your satellite capacity is going to have a few key places around the world where you're going to have your ground stations. It may or may not be in the same POP as your terrestrial connectivity ends up in. When you're getting terrestrial connections, you're typically going to, even if they're diverse, they're typically going to end up not that far away from your region. If you're in US East, if you're in Florida, for instance, um, getting to the Washington, DC area is not going to be a big challenge. With satellite, the satellite ground station could be in Texas, it could be in Los Angeles, or somewhere else. So it becomes very important to be able to bring capacity back to the same location, regardless of the connectivity mechanism that's available. So SD-WAN in that scenario plays a very big role. Um, now, because it's going to follow different paths and perhaps different providers. Having a layer of encryption is something that we found our customers value quite a lot. And then, of course, there's the um, segment of customers that have security as a baseline requirement, and that's going to be an important scenario.